Now let's see what is the Arrhenius theory of acids and bases. According to the Arrhenius theory in 1887, acids and bases are defined in terms of their structure and the ions produced when they dissolve in water. An acid is a substance that dissociates in water to form proton or H+. Two examples of Arrhenius acids are hydrochloric acid, which is HCl, and sulfuric acid, which is H2SO4. A base is a substance that dissociates in water to form hydroxide ion, or H negative. Two examples of Arrhenius bases are sodium hydroxide, NaOH, and potassium hydroxide, which is KOH. The Arrhenius theory explains acid-base reactions as a combination of proton and hydroxide ion. It provides insight into the heat of neutralization for the reaction between a strong acid and a strong base. Strong acids and bases dissociate completely into its ions in solution. For example, let's consider HCl plus NaOH. So both of them are strong acid and strong base. It's going to give us NaCl plus H2O. So that's basically typically a neutralization reaction between a strong acid and a strong base. And that's the delta H of reaction, which is negative 56 kilojoule. So if you want to write the total ionic equation, we can write H plus Cl minus from this one. And since it's dissociated completely, we can have Na plus and OH minus, and then it's going to be the same thing here. So basically we have sodium chloride in terms of ion in the solution. And then the net ions, we can write it like that. H plus OH negative is going to be water, which has the same delta H. And Na plus and Cl minus, they are called spectator ions because they don't involve in their reaction. Different combinations of strong Arrhenius acid and bases react with the same exothermic result. Measurements always show the release of 56 kilojoule of energy per mole of water form. This makes sense because the net ionic equation is the same regardless of the specific neutralization reaction that occurs. The Arrhenius theory has limitations. However, for example, a bare proton doesn't exist in water. A positive charge on a proton is attracted to the region of negative charge on the lone pair of electrons on a water molecule's oxygen atom. The combination is a hydrated proton, or is called hydronium ion. Hydrated proton, or is called hydronium ion, H3O plus. So we can write the reaction like that. So proton plus water is going to be hydronium ion. So as you see here, we have this kind of reaction, hydrogen bond on the water molecules. There's another limitation for Arrhenius theory. Arrhenius theory also has limitations for explaining certain reactions. For example, aqueous solutions of ammonia are basic. They react with acids in neutralization reactions, even though ammonia doesn't contain the hydroxide ion. Many aqueous solutions of salts with no hydroxide ions are basic too. So some reactions take place without any liquid solvent. For example, ammonium chloride can be formed by the reaction between ammonia and hydrogen chloride, and which are both gases. NH3 plus HCl is going to give you NH4Cl. So we can say that there are some bases that when they dissolve into water, they do not produce hydroxide ion. And also there are some bases that they can be dissolved in solvents as well. And as you see here, we have it in gas phase. This neutralization reaction is in gas phase, it's not in aqueous phase, and still we have neutralization reaction. So Arrhenius cannot answer this reaction. So these are the limitations by Arrhenius theory.